Welcome everyone to the study guide review video for the 7th grade Unit 1 test on scale copies and scale drawings. In this video, I'm going to go through every question on the study guide, which is super similar to every question that's going to be on the test. Okay, so if you can do all the questions on the study guide, then I'm sure you're going to get every question right on the test. All right, the first question says circle all the scaled copies of rectangle A. So when we look at rectangle A, we see that we have a height of 2 meters and a width of 8 meters. Okay, so that has the ratio of 2 meters to 8 meters. Okay, so if we want to make the ratio of the side lengths, and then we can set up the same sort of ratio for each of these and see if they are equivalent, because something we know about scaled copies is they have equivalent ratios, okay, for the side lengths. All right, so we can start for B. B will have 2 meters for the height, 8 meters for the base. Is that equal to 3 meters for the height, 12 meters for the base? Okay, if we put this into a calculator, or we could simplify it lots of other ways, this is going to be 0.25 as a decimal, or 1/4. And then this is also going to simplify to 25 hundredths, or 0.25, or 1/4. So yes, those are equivalent ratios. So B is going to be a scaled copy. And the scale factor would be 1.5. 2 times 1.5 is 3, and 8 times 1.5 is 12. But you don't need to do that for this problem. Okay, then we'll go and try C. C, we have 2 meters to 8 meters. See if that's equal to 4 meters to 16 meters. Okay, just looking at that, I can see that this is going to be a scaled copy as well. To get from 2 to 4, we multiply by 2, and 8 to 16, we multiply by 2. But we could also just check that this is going to be the fraction 25 hundredths, 25 hundredths. When we put this into a calculator and this into a calculator, we'll get 0.25. Okay, so C is also going to be a scaled copy. Okay, we can do the same thing for D, see if these ratios are equivalent. Looking at this, to get from 2 to 1, I divide by 2, and 8 divided by 2 is 4. So these are going to be equivalent ratios because we can do the same thing. Multiply or divide the numerator and the denominator by the same number, and we'll get an equivalent fraction or an equivalent ratio. But also we can just divide. 2 divided by 8 is 0.25, and 1 divided by 4 is 0.25. So that is an equivalent ratio. So again, another right answer, circling D. Then we can move on to E. 2 meters to 8 meters, is that equivalent to 3 meters divided by 9 meters? Note in all of these, I'm doing the heights in the numerator and the widths in the denominator. Okay, if we see this, 3/9 is going to be 1/3, or 0.3 repeating. 2 divided by 8 is 0.25. Those are not equivalent, so that is not a scaled copy. And then finally, we do the same thing for F. 2 meters divided by 8 meters, is that equivalent to 1 meter divided by 7 meters? 0.25 is not equal to about 0.14, which is what you're going to get when we do 1 divided by 7. So that one is also not a scaled copy. Okay, so when we think of scaled copies, we should think that there are equivalent ratios. And there's a scale factor, right? So like from here from A to C, we can clearly see a scale factor of 2, so we know that's right. And then maybe from A to D, you can also clearly see the scale factor of dividing by 2. But for B, you probably aren't going to see that scale factor in your head just by looking at it. So that's when it's most helpful to set up these ratios and check their decimal value and see if they're equivalent. Awesome. All right, moving on to 2. So 2 is a select all that is true question. These can be tricky just because, you have to go through every single question. So we're going to look at every single statement and evaluate whether it's true. We have polygon EFGH is a scaled copy of polygon ABCD. Select all of the true statements. First, segment GH is 3 times as long as segment AB. Okay, so first I'm going to find those segments. We have GH is here. GH is 9 units. And then AB is here. And that's 5 units. Okay, so if this were true, it would be like from 5 to 9, we'd be multiplying by 3. Is 5 times 3 equal to 9? No, so that one's not going to be correct. Also, looking at this, these are not, they're not corresponding sides. So whatever the scale factor is, these shouldn't be related. It's like this and this should be related because those are like in the same relative position, and AB and EF should be related, but they have to be like those corresponding side lengths. Okay, so not the first one. Then we have segment HE. So HE is right here, is 3 times as long as AD. Okay, so looking at this, they don't tell us how long AD is, but we can use the information we have. Since we know this is a scaled copy, that means there's a scale factor, and we can use any corresponding side length to find it. So here, this is 3, and this is 9. So the scale factor is going to be 3. 3 times 3 is 9. If I don't know that in my head, I can do 9 divided by 3, and it's going to give me 3. So the scale factor for this whole thing is going to be 3. And we know that these then are corresponding side lengths. So this and this, those correspond. So if the scale factor is 3, then yes, EH is going to be 3 times as long as AD. Okay, because they correspond, and that's the scale factor. So that's going to be correct. You wouldn't need to do it for what it's worth. That means that AD is going to be 6 units long because 6 times 3 is 18. Awesome. Okay, moving on. The scale factor from EFGH to ABCD is 1/3. Awesome. Okay, so when I said that the scale factor was 3, I was saying it in this direction from the smaller one to the bigger one. It's getting 3 times as large, all the corresponding side lengths. But then we want to think about it. What is the scale factor going to be if we're doing the reverse of that and we're going in the other direction? Okay, so the opposite of multiplying by 3 is like dividing by 3, but that's equivalent to multiplying by 1/3. So again, we want to get this relationship, a scale factor of 3 and a scale factor of 1/3. Those undo each other. They are reciprocals, and that is going to be this relationship. They go in the opposite directions. So that one is correct. Next we have the length of segment BC is 2. Okay, so here is FG, that's 6, and here's BC. Again, it's not labeled, but we can figure it out using this relationship, right? FG is 6, so to get from FG to BC, we would either multiply by 1/3, right? Going in this direction, multiply by 1/3, or you're just sort of asking yourself, what number times 3 is 6? So 6 times 1/3 equals 2, or 2 times 3 is 6. So, yep, BC is going to be 2 units. That is correct as well. And then finally, the area of EFGH is 3 times the area of ABCD. Okay, this is not true because area factor is not equal to the scale factor. So when we think about a scale factor, that's talking about how the side lengths of a shape are changing. so how many times bigger the side lengths get. But then when we go to find area, it's like you're factoring the scale factor twice. So the area factor is actually always different and generally larger. So anytime you see them kind of sort of a problem conflating how much the area is changing with how much the side length changes, it should red flag, nope, that's not right. Okay, so it's those middle three. Okay, question 3. A scale drawing of a rectangular park is 8 inches wide and 11 inches long. The actual part is 330 yards long. What is its area? All right, so here we have the scale drawing, and then we have the real actual park. Okay, and we need to find the scale and then use that to eventually find the area. So first of all, we want to use what we know. Okay, I know that the park is 11 inches long on my scale drawing, and it's 330 yards long in real life. So I can set up that ratio. 330 yards in real life is worth 11 inches in my scale drawing. And then to find its area, right, I'm going to need to figure out what the width is, or the height, or whatever we want to call it. Okay, and we know that in the scale drawing, it's 8 inches. So we want to figure out, okay, what is that in real life? We can use these equivalent ratios to figure this out. So want to figure out, what do I multiply 11 by to get 8? Okay, again, that's not something you're going to just sort of like know in your head. So you're trying to figure out 11 times what equals 8. To do that, to find this, you can do 8 divided by 11. So 8/11ths is going to be your answer. It's best to keep that as a fraction here, but it's equal to 0.27 repeating. Oh, sorry, 0.72 repeating. Okay, so then to get what the actual width is in yards, we're going to multiply the numerator by that same 8/11ths. Okay, so you could keep it as the decimal, or that, multiply by 330, and you should get 240 yards. If you're getting something different, it's probably because your calculator is rounding the decimal, but it should be actually exactly 240 yards if you like keep the decimal right, or you use it do it as a fraction. So then this is 240 yards in real life. And we are asked to find the area of the actual park. So to find the area of a rectangle, we know we just need to multiply 240 times 330. And when we do that, we're going to get 79,200 square yards. Okay, so the answer is D. So this problem requires two things. First, we have to use equivalent ratios and scales to find the height or the width of the park in real life, and then we multiply the side lengths to find the area. Beautiful. On to 4, we're supposed to draw a scaled copy of the polygon using a scale factor of 1/4. So, as we've been doing, we're going to figure out the original side lengths, and then you just multiply by 1/4. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 8 units originally. Base 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, this is also going to be 8. And then for this at the top, it gets a little bit trickier. So this is 4 units. Okay, and I think that's really all we're going to need. All right, so originally my base is 12. I'm going to multiply by my scale factor of 1/4, and that's going to give me my new base, 12 times a fourth, that is equal to 3. If you are trying to do that by hand, it's like 12 divided by 1 times 1/4, multiply straight across, 12 fourths, 12 divided by 4 is 3. Okay, but you will have a calculator on the test, so you can do that too. All right, so my base is going to be 3. Then I have my height of 8, so I'll do 8 times a fourth, and that's going to be equal to 2, 2, 2. And then my height of this is originally 4 of that like triangle top, so we do 4 times a fourth, and that is equal to 1. So I'm just trying to go 1 unit up, and this is like symmetric. Okay, so it should look like that, where that is 1. Cool. I mean, I added that, so technically that's not necessary, but it is important that that height should be just 1 unit above. Cool. So again, you just take the side lengths, you multiply by the scale factor, and then draw your shape. Okay? Question 5, Roberto is drawing a map of his town. He wants to include a school and a hospital, which are 15 kilometers apart. What should the distance between the school and the hospital be on the map? Okay, so in real life, we have they're 15 kilometers apart, and we're told for the scale that 2 centimeters is equivalent to 5 kilometers. So we'll write that scale down. Okay, 2 centimeters is equivalent to 5 kilometers. And then here we have 15 kilometers. So we're trying to figure out what should that distance be on the map. Equivalent ratios. How do I get from 5 to 15? I multiply by 3. So then I have to do the same thing up here. 2 times 3 is 6. So it's going to be 6 kilometers apart on the map using that scale. Sorry, not kilometers. So it's going to be 6 centimeters apart on the map, and it's 15 kilometers apart in real life. Cool. And then we have on the map, the school and the playground are 8 centimeters apart. So I can draw that. These are 8 centimeters apart on the map. And we want to figure out what the actual distance is. Again, we're going to use our scale. 2 centimeters is worth 5 kilometers. And in this case, we know we have 8 centimeters on my drawing. So then I say, okay, how do I get from 2 to 8? I multiply by 4. So then I have to do the same thing on the denominator. 5 times 4 is 20. So I'm going to get 20 kilometers in real life. So you just set up that equivalent ratio, figure out, right, what is basically the scale factor, what are you multiplying the numerator by or the denominator by, and then multiply the other one by that same number. All right, finally, question 6. I think this is the most challenging one on the quiz, or on the test. We have a trail runner gets a new map of her favorite mountain. Her old map had a scale of 1 centimeter to 400 meters. Her new map has a scale of 1 centimeter to 100 meters. If the maps represent the same area, will the new map be smaller, larger, or the same size as the old map? Okay, and then it's choose, and then you have to explain your thinking. Okay, so for this, what I find helpful, because you can do this without picking a number, but what I find helpful is to just make up an actual height of the mountain. So let's just pretend that the mountain's height is 800 meters. Okay, if the mountain's height is 800 meters, Then with the old map, to get from 400 to 200, you're multiplying by 2. So we do the same thing in the numerator. And 1 times 2 is 2. So in the old map, this mountain that's 800 meters high is just going to be 2 centimeters. Okay, now let's check what happens if we have the new map. So in the new map, 1 centimeter is worth 100 meters. Our mountain is still 800 meters tall. So then we'd say, okay, how do I get from 100 to 800? I'm going to multiply by 8. So in my new map, this mountain is going to be 8 centimeters tall. So the new map, the drawing is going to be larger because 8 centimeters is bigger than 2 centimeters. So will the new map be larger, smaller, or the same size? The new map is going to be larger. Okay, so that's sort of the way that I would figure it out. Some people are better at just doing this in their head and thinking about it than I am. All right, so the logic here is that the new map represents less real-life space in 1 centimeter. So, right, it's only representing 100 meters in 1 centimeter versus the old map, which represents 400 meters in 1 centimeter. So if it's representing less real-life space in that same 1 centimeter, it's going to take more of those centimeters to represent the actual space, right, the actual drawing. Okay, and so either you can sort of think about it conceptually like that, or you could draw an example like this and see how it's going to be more. Okay, and then finally, this is the related problem. We're still talking about this setup. She ran a trail that was 20 centimeters long on her old map. How long is this trail on her new map? Okay, so for her old map, we have this ratio. 1 centimeter is 400 meters in real life, and her trail was 20 centimeters long on her old map. So now we want to figure out, okay, what was that in real life? So to get from 1 to 20, I'm multiplying by 20. So then I can multiply 400 by 20, and that's going to be 8,000 meters in real life. Okay, so it's a lot of meters. So in real life, she's going 8,000 meters. So this is the old map. So now, given that, we have our new scale. So the new scale is that 1 centimeter is worth 100 meters instead of 400. But we know that the real-life distance that she went is 8,000 meters. So we're going to have that in the bottom in the denominator with the meters. And then we have to figure out, again, like, what are we multiplying by here? So to get from 100 to 8,000, that's a multiplication of 80. You're multiplying by 80. If you don't know that, you can do 8,000 divided by 100, and you'll get 80. So that's going to be 80 times as large. So then I do the same thing in the numerator. And that means that in my new map, it's going to be 80 centimeters long. So the trail is going to be 80 centimeters long on the new map. Okay, and then in terms of explain your thinking, we have really good work here. So just to put it a little bit in words, and first I use the old scale, 1 centimeter to 400 meters, to figure out that the trail is 8,000 meters in real life. Then I use the new scale, 1 centimeter is worth 100 meters, knowing that the actual distance was 8,000 meters. And then I, again, used my scale factor equivalent ratios to figure out that it would be 80 centimeters on the new map. Okay, as before, like with the one above, we should see that this is going to be bigger. 80 centimeters is a very big map. It was just 20 centimeters in the old one, so the new one is going to be larger, just like we said here. The new map should be larger. All right, so that's it. Last one's pretty tricky, but I'm sure you can figure it out. There's one it's identical. Like these problems are really identical to the ones that are on the quiz. So make sure you understand these. Come talk to me if you need help. Have any questions before the quiz. Good luck studying. Thanks for watching.